Hello everybody. So this is an introduction to the properties of radicals. We're going to be able to, hopefully at the end, add and subtract radicals, multiply radicals, and eventually down at the bottom divide, and possibly even rationalize radicals. So as an introduction, I'll say that I've written a rule, and you might want to copy that down. You can only add or subtract when they have the same radicand. And so I wanted to mention to you, this symbol is called the radical symbol. And whatever is inside of there is called the radicand. So when I'm looking at example number 1, and I'm going to zoom in on it right here. If you need to pause the video so you can write down vocabulary, whatever, feel free to pause anytime. So I've got a square root of 2 and I've got a square root of 2. They're both the same. That means I can actually add these things. And I would say there's a 3 out in front here. There's a 5 out here in front. The way I say this, and this is important, is that I have 3 square roots of 2 and I'm adding 5 square roots of 2. And that means I have 8 square roots of 2. It was that easy. Here, I'm noticing that I do not have the same radical. However, I remember simplifying radicals, that 8 is something that can be simplified. And I'll do it, right off to the side here. 8 is the same thing as 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. And so the square root of 8 is equal to square root of 2 will be left over with a 2 outside. And if you've watched my video on playing that marrying game, I'm marrying a pair of 2's. So I'm going to rewrite this now, and I'm going to say that this is really 4 times the square root of 2 plus, look at purple. Purple, I just changed this to be 2 times the square root of 2. I had 4 square roots of 2. I had 2 more square roots of 2. When I add those together, my answer will be that I have 6 square roots of 2. I always want to make sure I include an example where you can't add, and this is it. Square root of 3, square root of 7, can't add those. You actually just put a box around your answer. Right here, I get to put a box because I'm done. Since they don't have the same radicand, they cannot be added. All right, so now I'm going to move into some examples that have subtraction, and right away I see that there's a negative square root of 10 and there's a positive 9 times the square root of 10. These square roots of 10 definitely match, so I should be able to add, but you might want to remember that there is a hidden invisible negative 1 out in front. 9 minus 1 ends up being 8 square roots of 10 that I have left after I've done that subtraction. Now the square root of 27, thinking about 27, I totally know that that is 3 cubed. So that means it is the same thing as 3 times 3 times 3. I am getting these guys married. They leave the radical house, and I now have 3 times the square root of 3. So in purple, I will say that the square root of 27 is the same thing as, 3 times the square root of 3. And then I'm going to subtract 5 square roots of 3. And that means I am left with a negative 2 square root of 3. And just in case you're not following, I just wanted to mention that I gave you $5 and you gave me back 3. That means you still owe me $2. So that's my final answer here. And looking at problem number 6, like I said, I always want to include an example where you can't actually subtract. Square root of 5, square root of 2, they don't match. So I'm just going to put a box around it. That's as simple as it gets. Okay? Now, we've done addition, we've done subtraction. Noticing, very nice, that we have the ability to gather up a certain number of square roots of whatever it is we're looking for. With multiplying, it's a little bit different. Okay, and I want to focus on the rules here. It says break into prime factors in one radical, then play the marrying game. So if you watched my video on the best way to simplify radicals, I think you'll be in good hands. Looking at number 7, did you realize we just did the square root of 8? Yes, we did. So now I'm going to say that I had a 2 and I have the 3 2's that I multiplied together to get an 8. So 2 times 2 times 2 is 8. And now looking at who can get married in this radical house, I have 2 sets of 2. 2 times 2, which ends up being 4. Now, there are kids who do it another way. They're totally able to do it another way. 2 times 8 is 16. The square root of 16 is 4. That's great. If you can see that right away, I recommend doing it that way. It's a little bit less work. But for some of us, we just can't see what's being multiplied together until we write it down. So that's why I like to write it down. Now for number 8, you notice I'm giving myself just a little bit of room here. There is a negative 2. I'm going to write it down. There is a positive 3. I'm going to write it down. These guys already got married out of my radical house, and they become multipliers for my total problem when I put it all together. Now 15 is the same thing as 5 times 3, and there's a 3 right there. And so everybody who was inside of the square root is still inside of the square root, but I broke them apart so I can see who is getting married in my radical house. It's those square roots of 3. So I have a negative 2 times a 3 times a 3, and then I have a square root of 5. And my final answer will be 2 times 3 is 6, times 3 is 18, and so this is negative 18 times the square root of 5. So the last one is my example where there's not much I can do here. 2 is already prime, 11 is already prime, so what I'm going to do is I'm just going to multiply them together and say that I have a square root of 22, and that's as simplified as it gets. So now the last one, we have division, and there's a little bit of a trick to it, which is that if you have square root of something over the square root of something, you maybe didn't know this, but I am teaching it to you right now. You could put both of those things inside of the same square root. I call it a townhouse, because in a townhouse you get to live upstairs and downstairs, and it's all yours. And your neighbor lives next to you on the next side. They also live in a townhouse. They'll live upstairs and downstairs, and so on down the row of townhouses. So if I can do that, then that means if a over b is a fraction that can be reduced, sometimes that is something that helps me. So I'm looking at problem number 10, and I'm seeing 3 over 27. Now, literally, with my eyes, I am transforming it into the fraction 3 over 27. Now, reducing fractions is a skill that you want to perfect. 27 is a multiple of 3, so I'm going to divide this by 3. I'm going to get 1. I'm going to divide this by 3, and I am going to get 9. And everybody is still inside of the radical house until, again, I am noticing, hey, I really have, the original problem was something in a square root over something in a square root. And why would I go to this extra step? If you know that the square root of 1 is 1 and that the square root of 9 is 3, then you should be able to simplify it just like that. So I kind of call this, and this step is a little bit of an extra step. You don't have to do it. If you know that they could be in a townhouse together or they could be in individual apartments together, you can take the square root without actually writing that step down. All right, so number 11 then. Would it help for me to put these on the same square root? Sure, it would, because 6/8 is definitely a fraction that I can reduce. Both of those numbers are even, so I'm going to divide by 2. I'm going to divide by 2. I'm going to say that this is really 6 divided by 2 is 3, and 8 divided by 2 is 4. And I'm thinking about it, separate radicals. Why? Well, because the square root of 3, I don't know what it is. I mean, technically I do, but because I know stuff. But I'm just saying it's simplified. It's there. It's in my numerator. I'm happy. But the square root of 4 is definitely 2, and I knew I could simplify that. So now I'm double checking my fraction, and I'm saying, hey, was there an extra step here somewhere? Some of you guys may have been reading while I was, talking about how to divide radicals, and you saw this step. It said rationalize the denominator if necessary. And basically, the rule, and I'm writing this down in red, it's so important, you cannot leave radicals in the denominator. All right, do I have a radical here? No? Okay, I'm good. Number 11 is good, but 12, oh, that's a little bit trickier. Now, first of all, I will mention, what about 25 over 3? Is that a fraction that I can reduce? No, so I'm not going to try that. Instead, as I was writing down the square root of 25, I totally realized the answer to that is just 5. That's a radical I can simplify anytime I see it. So I just did that. But the square root of 3, that's bad. That falls against my rule. We wrote it in red after all. It says you cannot leave radicals in the denominator. So instead, what you need to do is rationalize it. So how do you rationalize? Well, I'll tell you what the trick is. You multiply by the denominator, okay? That's what you do. And by the way, what is this equivalent to? This is equal to 1. So I'm not changing the value of my fraction at all. I'm just making it look pretty. I mean, you know, such as it is, because 5 times the square root of 3 isn't really pretty. I get that. However, on bottom, though, I have the square root of 9, and I know that the square root of 9 is the same thing, ready, as 3. And this is a problem that, honestly, if you look at the beginning and you look at the end, I don't know which one's more complicated. They're kind of the same amount of complicated. I'll give you one more, though, okay? And this one I happen to have memorized. It's very interesting. It's very intriguing. Let's try it. It is 2 over the square root of 2. And this is the last one I'm going to do. Now, I'll just mention the reason why we rationalize the denominator is because back in the day when people did not have calculators, they happened to have radicals that they needed memorized, such as, for example, 2, the square root of 2 is 1.414. And I happen to have that memorized because it's very useful in trigonometry. So I say then that if I wanted to take 2 and divide it by the square root of 2, taking 2 and divide it by 1.414 is actually kind of hard for me to do in my head. Whereas watch what I'm about to do here. 2 times the square root of 2 is what I get on top. On bottom, I get the square root of 4, which is really the same thing as 2. Hey, these 2's canceled out, and my answer is just the square root of 2, which I already told you I had memorized, is 1.414. So sometimes when you rationalize the denominator, things do actually look simpler. And when you're first learning how to do it, that might not necessarily be true, but as we move into integrated 3, you'll definitely see there's times, and particularly in calculus, when it actually does look simpler because you did the rationalizing. So I would say for now, you still need to learn how to rationalize the denominator, and I have taught you that.